You're welcome to New Focused Approach to Mathematics Basic 8. This is the revised edition. And in this lesson, we want to look at translating word problems into linear inequalities in one variable and vice versa. So we want to learn how we can translate word problem into linear inequality and how we can also have linear inequality and create a word problem for it. Now, when we talk of inequality, okay, it always comes with inequality symbol like greater than, less than, greater or equal to, less or equal to. These are the symbols we normally see when we write inequality. When we see equal to, then it means equation. But here we are going to look at the kind of symbols. We call them inequality symbols. Now let's see how we can create a problem and then write inequality out of it. For example, if I say a number n is greater than 4, a number n is greater than 4, I can just write this, right? If I say a number x is greater than or equal to 9, is greater than or equal to 9, I can also write it this way. Very simple, right? Good. Let's see if I say 3 is less than or equal to a number. 3 is less than or equal to a number. 3 is less than or equal to a number. Good. What if I write a number m is at least 3? A number m is at least 3. That means at least 3 means that the minimum should be 3. It can be 3 or more. So since it can be 3 or more, we'll write m is greater or equal to 3. Let me explain this further. Assuming I want to give you a gift, or I'm going to give your class a gift, then I come and say that anybody who is at least 12 years will receive the gift. If you are in that class and you are 12 years, will you get the gift? Because I said anybody who is at least 12 years will get a gift. Will you get one? Assuming you are 12 years. Yes, you are going to get it. What if you are 13 years? Will you get it? If I say at least 12 years, yes, you get it. 14 people will get it. 15, 16, and so on and so forth. So it can be 12 or above. So if I say at least 3, then it should be 3 and above. So greater or equal to 3. What if I say a number p is at most 5? A number p is at most 5. That one too, at most means the maximum should be 5. And if the maximum is 5, then p should be less or equal to 5. That means nothing goes beyond 5. I hope it makes sense. Good. Let's say I write another statement like this. 12 more than twice a number is less than 25. 12 more than twice a number is less than 25. So 12 more than twice a number is going to be written as, so 2 times the number plus 12 less than 25. Good. What if I write 3 less than a number is not more than 5? 3 less than a number, take note of this very well. 3 less than a number is not more than 5. So 3 less than a number is not more than 5 means it should be less or equal to 5. That means it shouldn't be more than 5. It can be 5 but not more than 5. So we write it like this. All right. Twice a number more than 12 is at least 6. Twice a number more than 12 is at least 6. So twice a number more than 12 is at least 6 means that it should be more, greater or equal to 6. Okay, what about this one? The sum of twice a certain number, the sum of twice a certain number is greater than 13. The sum of twice a certain number and 3 is greater than 13, and so we write it this way. Okay, now let's do the other way around. What if I say translate this into word problem? What will you write? So here I can say 3 times a number. So I'll just say, okay, let me write this in words. So 3 times, so 3 times a number, or I can start by saying 4 less than 3 times a number is less than 8. So let me write it that way rather. 4 less than 3 times a number is less than 8. Simple. Okay, so 4 less than 3 times a number is less than that. Good. Okay, let's take the last one. What if I say write a statement for this? So here too you can say 6 more than half a number is greater than 20. Is greater than 20. I hope it's clear. So 6 more than half a number is greater than 20. Or you can say half a number and 6. Half a number and 6 is greater than 20. I'm sure with these illustrations, you'll be able to handle questions in terms of translating a word problem into inequality and vice versa. In our next video, we'll see how we can solve inequality problems. Thanks so much for watching.